Assalamu alaikum. This is the third class of transformations of functions in the P1 course, and we are going to start with reflection today. Okay. There are two types of reflection which we are going to study. The first one is reflection in the x-axis. Okay. And the second one is reflection in the y-axis. Okay. Firstly, we're doing reflection in the x-axis. Let's take the equation of a curve, assuming if we take y equals to x squared minus 2x plus 1. Okay, let's make the table of values for this and draw the graph. If I take the values to be a minus 2, minus 1, 0, 1, 2, okay, and 3, the values of y are going to be, if you just plug it into this equation very quickly, y is going to be with a negative 2, it will be a negative 2 square minus 2 into negative 2 plus 1. So 4 plus 4 plus 1, which is a 9. Okay, with a negative 1, it's coming out to be a 4. Okay, with a 0, it's a positive 1. With 1, it's a 0. With 2, it's going to be a 1. And with 3, it's going to be a 4. Okay, if I plot this on the graph, okay, with negative 2, I'm going to plot 9. With negative 1, I'm plotting a 4. With a 0, I'm plotting a 1. Okay. With 1, I'm plotting a 0. With a 2, I'm plotting a 1. And with 3, I'm plotting a 4. Okay, so I'm just going to draw this curve. Join the points with a smooth curve. Okay, likewise, it's going to go up. Okay, this is the graph. With 4, it should be a 9 then. Okay. Now, if I draw the graph of, if I multiply the whole of this equation by a negative, the graph is going to be minus x squared plus 2x plus 2. And if I take the values of x, similar values of x, and if I take the values of y, the value with a negative 2 is going to be a negative 9. With a 1, it's going to be a negative 4. With a 0, it's going to be a negative 1. With a 1, it's going to be a 0. With a 2, it's going to be a negative 1. And with 3, it's going to be a negative 4. Okay, if I plot these on the graph, with negative 2, I'm getting a negative 9, which is here. With negative 1, it's a negative 4. With 0, it's a negative 1. With 1, it's a 0. 2, it's a negative 1. And with 3, it's a negative 4. And with 4, it should be a negative 9 once again. Okay, if I join them with a smooth curve, you can observe that the graph of the purple graph, the blue graph is actually the reflection of the graph of the purple graph in the x-axis. That means if you multiply the equation of any graph by a negative sign and change the signs of every single term, the resulting graph is the reflection of the previous graph in the x-axis. I can give you another example. If y equals to x cubed minus 2x plus 1 or minus 2x plus 5, and if I want to reflect it in the x-axis, what I have to do is simply change the signs of all the terms, and now the resulting graph, which is this one, is going to be a reflection of this graph in the x-axis. That means the x coordinates will remain the same. The x coordinates, if you notice here, are the same, but the y coordinate, they have opposite signs. Okay, so like if the x coordinate is 0 here, The y coordinate here is 1, here is negative 1. With an x coordinate of a negative 1, the y coordinate is positive 4 here and it's a negative 4 here. So the x coordinates are the same, but the y coordinates are different. That means that the distance of every single point on this graph from the x-axis is the same as the different distance of these points from the x-axis. Take any point, okay, and the distance from the x-axis is the same as this point. The only difference is that they are on opposite sides of the x-axis. So we learned that in order to reflect a graph in the x-axis, we just have to simply change the signs. Okay, that means we can say that the graph of y equals to negative 5x fx is a reflection of the graph of y equals to fx in the x-axis. Now we are doing, after this we have to learn how to reflect a graph in the y-axis. Reflection in the y-axis. Now if I take the same example, y equals to x square minus 2x plus 1. Okay, the same graph which we have plotted here, so I'm just plotting it again on this. I'm just taking this and plotting it on the graph paper. Negative 2 with a 9, negative 1 with a 4. Okay, now if I simply, in place of every x in this equation, if I put a negative x, the resulting equation will be x square plus 2x plus 1. Okay, now if I simply make the table for this as well, okay, negative 4, negative 3, negative 2, negative 1. Okay, 0, 1. If I take some more negative values here, like if I take a negative 5 also. Okay, so if I plot the points and plug in this equation, like if I can just show you the first one, negative 5 square plus 2 into negative 5 plus 1, 25 minus 10 plus 1, which is a 25 minus 10 is 15 plus 1 is 16. So with a negative 5, it's going up to 16. Okay, negative 4, it's going up to negative 4 square plus 2 into negative 4 plus 1. 16 minus 8 plus 1, 17 minus 8 is a 9 here. With 3, it's going to be a 4. With negative 2, it's going to be a 1. With negative 1, it's going to be a 0. With 0, it's going to be a 1. And with 1, it's going to be a 4. Okay, if I take another value, if I take it to be 2, it's going to actually go up to a 9. Okay, let's plot this on the graph. Okay. Negative 5 with a 15. So it's beyond the, it's not going to fit in my graph. So I'm starting with a negative 4, which is 9. With negative 4, it's going up to 9. With negative 3, it's 4. Negative 2, it's 1. Negative 1, it's 0. With negative 0, it's a 1. And with 1, it's a 4. And with 2, it's a 9. If I join these points and make the curve, what are you observing here is that every y coordinate is the same, the x coordinates have changed their signs. Okay, so we can say that the graph of y equals to f of negative x is a reflection of the graph of y equals to f of x in the y-axis. Okay, so you are actually reflecting the graph in the y-axis. So this point has gone on to this point, okay, and this point has gone on to this point. So whatever is the distance from the y-axis, the reflecting point, the graph of y equals to f of negative x has the same distance apart from the y-axis. It's a reflection in the y-axis. This whole part has gone onto this, and this whole part is the mirror image of this part is the mirror image of this. Okay, so we come to the conclusion that the graph of y equals to f of negative x. That means whatever was the equation of f of x, in place of every x you have plugged in negative x. Okay, so it's a reflection of the graph of y equals to f of x in the y-axis. That means the y coordinates remains the same, but the x coordinate, they changes their sign, so they are the same distance apart from the y-axis. Take any y coordinate, like for instance this one. The y coordinate is obviously the same. The image of this is this, so the distance is 4 units here, 3 units here, 4 units here, so this distance is also 4 units. Okay, so the image of this point is this point, the image of this point is this point, the image of this point is this, the image of this is this. This point remains the same because this is the invariant point which lies on the y-axis. Any point which lies on the line of reflection is the invariant point. Okay, likewise the image of this point is this point, and the image of this point is this point. Okay, let's do this question. It says the quadratic curve y equals to f of x has a minimum point at the minimum at the point 5 comma negative 7. Find the coordinates of the vertex and state whether it is maximum or minimum of the graph for each of the following graphs. If it is negative 5x, that means you're reflecting the graph in the x-axis. If you're reflecting the graph in the x-axis, assume negative 5 comma 7 is 5 comma negative 7 is this point. Okay, and this is a minimum point they've told us. Just drawing a rough sketch. Okay, now if you want to reflect it in the x-axis because of the negative sign outside, it's very evident that you're reflecting it in the x-axis. When you're reflecting it in the x-axis, so this turning point, which is a negative 5 comma negative 7, is going to go on to 5 comma positive 7. So the vertex is going to be, it will be a reflection in the x-axis, so the vertex is going to be 5 comma negative 5 comma positive 7, and it will be a maximum graph. Okay, moving on to the B part, it is very evident from here that here we are asked to reflect the graph in the y-axis. Okay, so if this was the vertex 5 comma negative 7, okay, if this was the graph, original graph, and you're reflecting in the y-axis, this point 5 comma negative 5 is going to go on to negative 5 comma negative 7. The x coordinate will change the sign, the y coordinate will remain the same. So now it's going to be somewhat like this, and that means the vertex has shifted to minus 5 minus 7, and it is going to stay a minimum graph. It will be a minimum graph. Okay, moving on to question number 1 here. The diagram shows the graph of y equals to g of x. State the graph of each of the following functions. Negative gx meaning reflection in the x-axis. Okay, so if you have to reflect it in the x-axis, what are we going to do here is, whatever is the distance apart from the x-axis, this point is 1 unit up, so go 1 unit down and mark the points. Okay, 1 unit down for this one. This point is 3 units away from the x-axis, so 3 units down on the opposite side. It's going to be this, you're going to mark this point. Likewise, this point is 2 units down, so you have to, the reflection of this point is going to be 2 units up the x-axis, so it's going to be this point. I'm going to join them and make the graph, which is actually a reflection in the x-axis. This is the first part. Okay, for the second part of the question, if I can just copy it here. For the second part, they are saying y equals to g of negative x. It is evident from here that they want us to reflect the graph in the y-axis. Okay, for the reflection in the y-axis, what we will do is simply take the point and see what is the distance from the y-axis. 3 units from the y-axis, so on the other side 3 units you have to mark. Okay, this point is 1 unit, so 1 unit here. This point is 2 units on this side, so you have to mark 2 units on the opposite side of the y-axis. Same distance from the y-axis. Likewise, this point is 3 units on this side, so it's going to go on to 3 units onto this side, will be this point. And then you can actually join them and make the graph. Okay. So this is the graph for y equals to, I can copy it here. And this was the original graph. Moving on to question number 2, find the equation of each graph after the given transformation. Y equals to 5x square after reflection in the x-axis. Reflection in the x-axis, you just have to simply change the sign of the term. There's just one term, change the sign. This will be the answer. Reflection in the B part, reflection in the y-axis. If ever it's a reflection in the y-axis, in place of x, you have to put negative x. So it's going to be y equals to 2 negative x to the power of 4. We know that if it's an even power on a negative, on a bracket which has a negative term in it, because of the even power, this will become positive and it will become 2x4. The reason for this is that this curve is actually symmetrical. The line of symmetry is the x-axis, so there's no effect. This side of the curve has gone onto this side and this side of the curve has gone onto this side. That's why there's no change in the equation. The C part, after reflection in the y-axis, after reflection in the y-axis, that means in place of every x you have to plug in minus x. So the equation will be 2x square plus 3x plus 1. The D part, reflection in the x-axis, change the sign of every single term. It's going to be y equals to negative 5 negative 2x plus 3x square. Okay, or you can write it as 3x square minus 2x minus 5. So these are the 4 questions done. Moving on to the next question, which is describe the transformation that maps the graph this onto the graph of this. Okay, if you notice here, they have actually changed the sign of every single term. This was positive, it has become negative, positive, negative, negative, positive. That means they have multiplied the whole of this equation by a negative. That means it's a reflection in the x-axis. A part, it's reflection in the x-axis. Okay, in the B part, if you notice, this has gone onto this. They haven't changed this sign, they have changed this sign. That means it's not reflection in the x-axis. If it would be reflection in the x-axis, every single sign should have changed. This should be a negative here, but they haven't changed the sign. So that means in this case, what you will do is check if it's a reflection in the y-axis. How? You have to put a negative x in place of every x and see what is the equation which you're getting. I'm getting x square plus 3x plus 4, which is exactly the same as what they have given. So that means it's a reflection in the y-axis. The C part, they are saying y equals to 2x minus 5x square. On the graph, y equals to 5x square minus 2x. They've changed the sign of every single term. So negative has become positive and positive has become negative. So it's reflection in the x-axis. It's just observation which you're doing. Likewise here, if you check if every such term has changed the sign or no. Positive has become negative, positive has become negative, negative has become positive, and positive has become negative. That means this is also reflection in the x-axis. Okay, here we come to the end of this video. What have we learned today in this video are the 2 facts which I want to just repeat. The graph of y equals to negative 5 f of x is a reflection of the graph of y equals to f of x in the x-axis. If you simply see that every single term has changed the sign, it is purely a reflection in the x-axis. But if you see some discrepancy, meaning every single term has not changed the sign, just check by substituting a negative x in place of every x and see whether you are getting the resulting equation. If yes, then it's a reflection in the y-axis. Thanks a lot for watching the video.